Lisa. I'm working for Granite, especially in the field of waste-to-energy technologies. And I want to introduce our newest technology, our test machine for converting plastic waste into diesel. And maybe I show you the material. This is the kind of material we are working with. This is paper and mixed plastic waste. This is in future that what we are treating, but for setting the machine into operation, we have here standard mixture out of polypropylene, polyethylene, polystyrol, ABS, and so we know exactly what we are feeding, because we want to make mass balances, energy balances, and so on. The system is very special. What you see here is the feeding. You have a conveyor. The screw conveyor feeds it to the top, where the plastic is compressed, because you want to get the air out, and it is flushed by nitrogen. You see the nitrogen tanks here, as to have totally inert material inside of the system. So you have security and no explosive problems. The next step is, because you have to wash that material, and when you wash it you have water in the plastic, and with that we do not want to have the water inside of the melting, so we heat it up to 100 degrees and flush it out of the system on this little hook, and then it is condensed in the water condensers. Also, that is always flushed with nitrogen. Then you heat it up on this long, up to 300 degrees, as to melt the plastic. But it's not cracking here, it's only melting and making it liquid. Then you introduce it into this part with a big chamber. This is the so-called cracking reactor. If you follow me, the molten plastic is transported by a screw conveyor into the crack reactor, and with the outside spirals transported upwards to the column, to the distillation column. We use internal spirals because any kind of cracking process cracks the molecules with the long chains and creates carbon. And the carbon has a tendency to build up a layer on the wall, and that's why we're cleaning it always with the spirals. So you have no layers on the wall. And that's the carbon coming from the depolymerization. And you let it out at this system. This is the outlet system, and this is pure carbon with a little bit of tar in it, because the tar is also not evaporating.
You can reuse it for the furnace?
You can use it. It's really burning. Then what you see here, this is an emergency exit. If something happens, the system could be emptied in 30 seconds. Full automatic. So we have no risk. If you follow me, the gases are going into the distillation tower, where they are liquefied again. Because here it is fully gas. Here you produce it in a liquid. Only on top of the liquid the gas goes to the partial condenser. And that's one very unique thing with the system. The partial condenser makes all carbohydrates longer than 24 carbon atoms to condense and flow back into the reactor. When they are longer, then they are cracked until they are short enough to pass over the reactor. Then these which are passing are condensed in a spray cooler with 30 degrees Celsius. So having only C24, the big advantage is that this is a diesel characteristic. The chain should not be longer than 24 carbon atoms. The molecules which could not be condensed at 30 degrees, this is methane, heptane, all these parts, these are staying gaseous and are later used to fire and to give the external energy. Here we are using electricity for the test machine to heat it from outside. Another very important part of that is when you want to make pure liquid, then you have to crack at relatively low temperatures. Because if you go to very high temperatures, like competitors do, then you have the problem that from 550 to 600 degrees on, the molecules, the carbohydrates, are cracked into carbon and hydrogen. And this is what we do not want. We do not want to produce hydrogen in the machine. In the moment we have excellent results. We have a pure spectrum of C10 up to C24. We made a lot of gas chromatography research, and it is no sulfur, no heavy metals, no containing. It's an excellent material, and we produced wonderful winter diesel by condensing at 30 degrees, because then we have the light molecules also in it. And when we want to make summer diesel, we are raising the temperature up to 60 degrees. Then the small molecules are not condensing anymore, and we have only C9 to C24. This is the summer diesel. The winter diesel has volatile material like benzene, pentane and all that kind of material. So we can produce direct the diesel quality what we want. You can put it into your diesel when you want, but I do not believe that the tax will like it, because they want the road tax on top of it. So what we do is we fire it in the moment in the central heating. Since 5 days without any emissions, it's like natural gas. Maybe I can show you a little bit.
Hast du eine Probe?
Really the material coming out. That's a pure diesel liquid, and if you want, it's diesel as a present for our people. And maybe there are a lot of open questions, but one comment: the big machine will make about 3 tons per hour, and the price per liter, the full cost price per liter, will not be more than 40 Rappen or Swiss centime, which is much less than a momentary diesel price. So this would be a very effective method to make money and make our future customers happy. Thank you very much.
Thank you. I have one question. What is the capacity right now of this installation?
You mean the size? Or
Yeah.
it can make maximum 200 kilogram per hour, but we run it in the moment at 50 to 80 kilograms per hour. The reason is we want to change the material, the different types of polymers. That's why we have not a bigger size.
Thank you very much.